Hello. In these videos, we are going to see some examples of functions. Functions are a very important part of mathematics, and we are going to review some of the ideas. Which are the objectives of this slide? The main idea is to review several types of functions like power functions, exponential functions, trigonometric functions, etc. And to plot some of them, because knowing or remembering the plot or the shape of these functions is very important. At the end, this will help you during the resolution of problems. Requirements are small or few, if you want to say it that way. Some basic algebra, some basic trigonometry, and some properties about exponents, radicals, and trigonometry identities. But I will try to explain all of them during the video. Okay, in this slide we have some of the important functions we are going to deal with during these videos. Power function is a function that, as you see here, is defined as x powered a number. X is the variable, is called the base in here, and n is the exponent. N could be a real number also. Okay, exponential functions are a little bit different. In this case, it's a number, powered to x, where a is positive and different from 1. Trigonometric functions, okay, there are many. In this case, I just wrote 3 of them: sine, cosine, and tangent. It's important to know how to use them, and it's important also to know several values of sine, cosine, and tangent. For example, what is the sine of pi over 6? What is the cosine of pi over 3? Or tangent of pi half, for example. Okay, so these functions are important, and we should know a little bit of them. We will see in the graph that the plots are very easy to remember. Another function is polynomial functions. It's are functions expressed in terms of the form an xn. This number that multiplies x power n, it's called the coefficient, and n is the power of the polynomial. The highest value you have here is the degree of the polynomial. For example, look at the final example: 2x cubed minus 3x squared plus 4 times x minus 5. This is a polynomial degree 3 because it's the maximum exponent is 3. Okay, and the coefficients of this polynomial is 2, -3, 4, and -5. That will play an important role when calculating limits and derivatives. Knowing what is the coefficient, we will mention many times, and it's good to know. It's good to know. Okay, example: x cubed. X cubed, it's a function. It's an increasing function, as you can see. It's negative between 0 and minus infinity, and it's positive between 0 and plus infinity. Okay, it's a very common function. I could have plotted x squared, that you know is the parabol, but x cubed, it's also a very important function, polynomial, and it's going to appear many times. So here you have one. In this plot, in this graph, even it's a little bit complicated. Be careful with the graph. We have plotted different power function like x powered to 1, x squared, x cubed, x to the 4th power, x to the 5th power. Okay, be careful because I just added x cubed, and one of the most important things you must take care when looking at this picture is that the x-axis and the y-axis are not in the same rate. I mean, look at this. 0, 2 is here, and on the y-axis it starts at 0, and this is 20. Okay, it's not plot 1 to 1. It's just proportional in this case. So as you can see here, x is the straight line passing through 0, 0, and this straight line should divide the quadrant in 2 equal parts. In the plot, it's not well seen, again, because of the difference between the scales of x-axis and y-axis. But if we wanted to plot everything together, it's very difficult. So take this into account. So this is the straight line is here, okay, in blue. X squared is that plot here and here. Is the parabolas, the one you know. Looking in this picture, again, the scales are different and looks like very flat or something like this. Okay, be careful with that. X cubed is in green, it's plot like this. Then x to the 4th power, recall the idea of x squared. Look at this, it's x to the 4th power is here, and it's very similar to x squared. Okay, and x to the 5th power, it's the one in purple, it's going like this and like this, okay? So they are very similar. When the exponent is even, they are very close, and when the exponent is odd, they are very close. And okay, be careful when I say very close, it's not so close, okay? But the shape is more or less the same, what I'm trying to say here. Okay, exponential functions. Two important exponential functions. I think this is something that we also must remember many, and it's going to be used many, many times. For example, the exponential functions, when we take, remember that the exponential function, the shape was a power x, when a, the number could be any number. If we take the number e, then we have this kind of exponential function that looks like this. Look, the plot is increasing, an increasing function. It passes through the point 0, 1, and this is very easy to calculate. When you replace the value of x by 0, e power 0 is 1, so it's going to pass through this point. But and it's a very fast increasing function. Increases really, really fast. It's very common to say that something is growing exponentially. That means that it's increasing very, very fast. When we change the exponent by negative x, then it's a decreasing function. It's a symmetric function with respect to the y-axis, but it's decreasing. An important thing about this is that, as you can see, this function approaches the straight line y equal to 0. So it's approaching this value more and more. The farther we go, the closer to 0 of this function is. We will see this in limits again, but it's a good time to remember this, okay? The idea is that when x tends to or approach plus infinity in this function, the function tends to 0, okay? And it's decreasing very fast also. Okay, more functions, sine and cosine, very common functions. Sine is plotted in blue, cosine is plotted in yellow, and as you can see, it's a periodic function. It's going up and down, and a very important property. The maximum value these two functions are going to reach is 1, and the lowest value is going to be -1. So we say that these functions are bounded. It's like they are limited in the y-axis. They cannot go to infinity, or they cannot go to minus infinity. These two functions are bounded, okay? So remember that, because it's important, and it's a very helpful property that we will use. Tangent, okay, this is different. Tangent is not bounded. As you can see, tangent goes to plus infinity and starts in minus infinity, and this value in the middle, it's going to be called vertical asymptote. But the main point in here is just to remember what was the shape of the tangent, and the tangent is not well defined for some values. That makes sense if you remember that tangent is sine over cosine. Anytime cosine is equal to 0, the tangent is not well defined. Okay, so we will have vertical asymptotes again and again and again. This is also a periodic function. It's repeated along the real line. Okay, polynomial function. Let's combine some power functions like this: 2x cubed minus 3x squared plus 4 times x minus 5. This is x cubed. The shape remembers the one of x cubed. And the plot is like the one you see here. How do you obtain this plot? How do you obtain this graph? Just by giving values to the x. At the end, you can join all the values and see the shape of the function. Okay, guys, what have we seen in this video? We have just reviewed the idea of power functions, exponential functions, trigonometric functions, polynomial functions. There's still time. There will be time to see, for example, logarithm functions that haven't appeared in these slides. We also have seen some plots of the main important functions, and we have seen that they are important in mathematics. Okay, guys, thank you for your attention. See you in the next video.